Welcome, scholars, to Lesson 3.4, Interpret Functions. We're going to be identifying independent and dependent variables. We're also going to be writing a function and evaluating it. So let's get started. The variable that represents the input values of a function is the independent variable. Because it can be any value in the domain. So independent variables, those are going to be our x values. Those are going to be the things that happen no matter what. So that's usually going to be something like time, something that happens, that just occurs, that will happen no matter what. Then the variable that represents the output values of a function is the dependent variable. Because it depends on the value of the independent variable. So again, our dependent variables, that would be our y values, and that would be things that depend on what's happening independently. So that's usually going to be, like our money, our total cost, our, height of a plant, or it could be a number of different things, but our dependent variable always depends on the independent variable. When the equation represents a function, the dependent variable is defined in terms of the independent variable. The statement y is a function of x means that y varies depending on the value of x. So let's look at example number 1. Super Awesome Sneakers is a monthly subscription service that sends you a new pair of sneakers every month. The cost is $120 to sign up and $50 per month. So let's define our independent and dependent variables. So there are two things that are happening here, right? First would be the months, right? You are subscribing to this every single month. So that's our first variable. That would be our months, our time. And then the cost, right? Our total cost is also going to be a variable. That's what's changing as well. So which one is independent? Which one is dependent? Well, first, let's start out by writing independent as just writing x. And then, again, remember my hint, the independent is usually going to be something like time because that occurs no matter what. So in this case, our independent variable is going to be our number of months. And now for our dependent variable, which is going to be y, what depends on the number of months? And that's going to be our total cost. So again, how did I define my independent and dependent? Well, I thought about what was changing in this situation, right? That would be the months that I'm subscribing, and that would be what I'm paying. So then how do I know which one is which? Independent is usually time. It happens no matter what. So our months is our x, and our total cost is depending on how many months we have it. So that's our dependent variable. Now we're going to write a function relating the two variables. And so if you remember back to our inequality word problems, what happens is we have to think about what we are kind of spending or what's basically happening. We can look for clues to know if we're going to be multiplying. So let's start off with just, actually to the side, we're going to write our words. What is happening? So our total cost, what we're spending, right, is going to be equal to, and so what's happening? What are we spending money on? Well, there is a sign-up fee. And then we are adding to that a monthly charge or a monthly fee. So now that we've written it in words, let's go ahead and actually write the function, which is, now we could write it as f of x, or we could just write it as y equals. We're going to go ahead and write it as y equals. So y is equal to, because remember our total cost is y. And then our sign-up fee is $120 to sign up. So that's going to be $120. And then it's $50 per month. Again, back to when we did our inequality word problems. That per means that I'm going to be multiplying $50 times the number of months. Since I don't know how many months, I'm going to use x. So it'd be plus 50x. So it does kind of look like our word problems that we just finished, because we actually have a constant, right? Something that's happening, that like an initial cost, initial sign up fee. And then we have something that is changing. So it's the $50 every single month. And that when we talk about slope, we're going to, talk about that in a little bit. But hopefully we understand how we got this as our function. So now our last part here would be, what would f of 5 represent? Find f of 5. So another way we could write this is also f of x is equal to 120 plus 50x. So this is just saying, what would f of 5 be? So either of these are, I'll take either of these when we are, submitting answers. So f of 5, that means if x is 5, what does that mean? So f of 5 let's say represents the total cost for 5 months. So again, how did I get that? Because f of 5, so that means 5 is x. And what does x mean? It's the number of months. So f of 5 must be 5 months. So it represents a total cost for 5 months. And now let's find f of 5 by putting, and let's just go back to using the y equals. Let's go back and put 5 in for x. So to find what f of 5 is, I'm going to replace x with 5. That's it. So 120 plus 5 times 5 is 25. 120 plus 25 is $145. And that is my answer for letter D. I'm going to go on and do a couple more examples. Let's look at example number 2. Super Awesome Cell Phones is running a promotion in which a new phone costs $500 and the data plan will be $35 per week. So what is the independent and dependent? Again, independent is going to be time. So that would be my number of weeks. Again, how do I know that? Because it happens no matter what. Now, what is depending on the number of weeks? That's going to be my total cost. Again, usually y is going to be total cost, or just the total of whatever we're measuring here. In most cases, it will probably be money. And now we're going to write a function relating the two variables. So again, y is, we're not going to do the words every time, but y equals, hopefully you understand that there's going to be initial fee or initial or a starting point. That's going to be that the new phone costs $500. So 500 goes first. And the data plan is 35 per week. So again, per, so $35 times the number of weeks. Weeks is x, so 35 times x. You just write it as 35x. Again, I'm spending my initial cost, I'm spending my monthly cost, and then that's all equal to my total. So f of 3, that represents, again, going back to x is number of weeks. So f of 3 represents the total cost at 3 weeks, or is it, did I say after? Or I said 4. The total cost for 3 weeks. Let's keep it consistent. But yeah, after 3 weeks or for 3 weeks, doesn't really matter. Now I'm going to find it. So I have to plug in 3 for x. 35 times 3. 35 times 2 is 70, plus another 35 would be 105. And now 500 plus 105 is 605. So my total for 3 weeks is $605. All right, one more. Levi bought a bag containing 50 small candies. He starts eating the candies at a rate of 4 candies per minute. So now there's a little bit different. There's no total cost, but there's time, right? So let's identify independent. which would be the number of minutes, right? Because our time in this case is minutes. Now, it doesn't always have to be time. It could be something else, but just in these cases, it is time. So number of minutes. And now our dependent variable is what is depending on the number of minutes. So what are we measuring here? It's not money, but in this case, it says candies, right? So my y, what is dependent, is going to be the number of candies. And I believe, let's be a little bit more specific, it should be number of candies remaining in his bag. Remaining in the bag. So you have to just kind of think about it. If he bought the bag, he has 50 and now he's eating them, right? So our variables are going to be the minutes and also how much he has left because he's eating 4 per minute. So our function is going to be y equals, so our total, right? Our total is still going to be our total. So what is that? What did he start with? He started with 50. So our initial, instead of it being a fee, it's going to be our initial amount of candies, which is 50. And now in this case, we're not adding because if he's eating them, right, they are going to be disappearing. So we're going to go ahead and subtract, right? He is eating 4 candies per minute. So we are going to subtract. We're going to take them away. So 4, and then the number of minutes is x, so minus 4x. Again, this is different because there's no money, but he's starting with 50. He's eating 4 per minute, so we're subtracting 4x. So our total, again, our number of candies remaining in the bag is going to be 50 minus a multiple of 4. However, many minutes he's been eating will give us our total remaining in the bag. So what would f of 7 represent? Again, so still, even though we're still dealing with time, right? Our f of 7, when 7 is x, so that means that would be, let's see if you can get it. What would f of 7 represent? You can go ahead and pause and fill it out yourself or just keep listening. So f of 7 represents the number of candies remaining after 7 minutes. And then let's go ahead and actually solve it. So y is equal to 50 minus 4, and I'm going to replace x with 7. 4 times 7 is 28. And 50 minus 28 is, so 2 more makes it 30. 30 to 50 is 20, so 22. There we go. So 22 candies should be in Levi's bag after 7 minutes because that means he's already eaten 28 of them. All right, scholars, good luck with the practice. Let me know if you have any questions, and you got this.